Okay, for this one, so before we choose u, I'm going to rewrite the function in slightly different form. Okay, so the integral is equal to the integral of 1 over, I think you have cube root of x squared minus 4. And then you have x in here. Okay. You remember what I said about how to choose u? Choose u to be a function of x, so that one of the two factors becomes a function of u with easy to compute antiderivative. The other function is the derivative of u times a constant. Okay. Anybody want to tell me how to choose u, or write down how to choose u?
X squared minus 4, sir.
Yeah, x squared minus 4 is right. Cool. So can I divide the thing into two parts? So let u be x squared minus 4. Okay. And then one function will become 1 over cube root of u, which is essentially a power function, right? So the other function is the derivative of u multiplied by a constant. Okay. That's how it works. Okay, now the next thing we do is to compute du. Du is called the differential of u, right? The differential of u, you take the derivative of x squared minus 4. You'll have 2x and then times dx, right? After that, after that, we are almost ready to write the given integral entirely in terms of u. Okay. Again, one function is can be written as a function of u with easy to compute antiderivative. In method 1.1, I told you you can imagine a box. So the other function, so which is the derivative of u times a constant, together with dx, the factor of dx, you put that in the box. And then from the differential, I wanted you to solve that equation for the box. Okay. This will help write the given integral as a new function, as a new variable of u. The stuff I boxed is here in the differential. Actually, as long as you choose u properly, then the stuff in the box can always be written as a number times du, as a constant times du. Okay. And then we solve that equation for the box. We want to write the stuff in the box as a number times du. Okay. So x times dx, the stuff in the box, can be written in terms of u as 1/2 times du, right? You divide two sides of the equation by 2. You have that. After writing the stuff in the box as a number times du, then we are ready to write the given integral entirely in terms of u. Okay. Okay, I will show you that. The given integral now, we are ready to write the given integral entirely in terms of u. Okay. Yeah, probably you want to look at here, so which is the same thing as the given integral. Okay. That factor can be written as a function of u as, so do not forget the integration notation. That factor is written as a function of u as 1 over cube root of u, right? So because our u is x squared minus 4, you have cube root of u on denominator. Okay. And the stuff in the box is half of du. I can leave the constant factor 1/2 out of the integration notation. So you have dx in here. Okay. Sorry, du. You have du in here. Again, Now we have an integral of u. Do not write x and u in one integral. Okay. The radical function here is essentially a power function. Convert the function to the form of a power function, so we can use the power rule. Okay. So here we have the indefinite integral of u to the power of negative 1/3, right? Negative 1/3. Now we are ready to apply the power rule to get the antiderivative of u to the power of negative 1/3. So we have 1/2. To get antiderivative of negative 1/3, so you have u to the power of negative 1/3 plus 1. I'm talking about the power rule. Okay. Negative 1/3 plus 1, I think you have 2/3. And then if your exponent is 2/3 in here, you invert the numerator and the denominator. You have the coefficient before the function. Okay. You should have 3/2 in here. Okay. Right. Invert 2/3, you have 3/2. Okay. And then plus c. Do not forget c. Do not forget c. Okay. In the last step, we are going to write the final answer as a function of x. We combine these two factors. We have 3/4. 3/4, and then we replace u. The relation between u and x is always here. Okay. We write u as x squared minus 4. So we have x squared minus 4, and then to the power of 2/3, and then plus c. Okay. When talking about integration techniques, we do not simplify. In most cases, we do not simplify. So by that I mean you can leave the final answer like that. You do not have to convert the answer as a function of as a radical function or whatever thing. Okay.